Hello. Thanks for joining us today. I have had a chance to look over your resume, and it looks like you have about 4 years of experience with Angular. We are looking for someone who can not only write features, but also help us architecturally and maybe mentor some of our junior developers. How are you doing today?
I am doing great, thank you for having me. I have been looking forward to this. Over the last few years, I have shifted from just completing tickets to really thinking about the long-term maintainability of the apps I work on, so I am excited to discuss how I can bring that perspective to your team.
That is great to hear. Let's dive right in. I want to start with some fundamentals, just to get a feel for how you explain concepts. For someone who is just starting out, how would you describe the primary purpose of an Angular component?
I usually explain it as the basic building block of the entire user interface. Essentially, a component is a way to encapsulate a specific patch of the screen. It combines a TypeScript class which handles the logic and data with an HTML template that defines the visual structure. By breaking a complex page into these small, independent, and reusable pieces, we make the code much easier to organize and maintain. If you need a search bar or a user profile card, you make it a component once and then you can drop it anywhere in the app.
Right, and once you have those components, you usually need to share logic between them. That is where services come in. In your experience, what are Angular services primarily used for?
Services are all about separating concerns. While components should focus on how to display data to the user, services handle the heavy lifting. I use them to organize and share logic, data, or functions across different parts of the application. For example, instead of writing the logic to fetch a user profile in 3 different components, I put that logic into a single user service. This makes the code reusable and keeps the components lean. It is also where I handle state management or complex business calculations so that the UI layer stays thin.
Speaking of services, I noticed you mentioned state management. Let's talk about the provider's array in the component metadata. When would you put a service in the provider's array of a specific component rather than providing it in the root?
That is an important distinction for managing the lifecycle of a service. When you provide a service in the root, it is a singleton, meaning every component in the app shares the same instance. But if I list a service in the provider's array of a specific component, Angular creates a new instance of that service specifically for that component and its children. This is called component-level providing. I use this when I have state that should only exist as long as that specific part of the UI is visible. Once the component is destroyed, the service instance is destroyed too. It is also very useful if I have a page with multiple independent widgets that each need their own separate state without interfering with each other.
That makes sense. Now, as an app grows, you often run into architectural hurdles. One common one is the circular dependency. Can you explain what that is and how you would handle it in a professional project?
A circular dependency happens when 2 or more classes depend on each other in a loop. For instance, service A needs service B to function, but service B also requires service A in its constructor. When Angular tries to instantiate these, it gets stuck in an infinite loop because it cannot finish creating one without the other already existing. I usually detect this through console warnings during development, but for larger projects, I might use a tool like Madge to visualize the dependency graph. To resolve it, the best architectural practice is to extract the shared logic that both services need into a third, smaller service. Both service A and B can then depend on this new shared service without needing each other. If that is not possible, I might use a forward reference or inject the dependency manually inside a specific method, instead of the constructor to break the loop during the initial instantiation.
Good. Let's move toward data fetching. You'll be using the HTTP client module quite a bit here. What is the actual purpose of that module? And how does it differ from just using the native fetch API?
The HTTP client module is a built-in wrapper around the browser's native fetch or XML HTTP request. While fetch is great, HTTP client provides a much more powerful and consistent toolkit for Angular developers. It gives us the HTTP client service, which handles common operations like get, post, put, and delete. The big advantage, though, is that it returns observables. This allows us to use RxJS operators to handle asynchronous data, map responses, or even cancel requests if a user navigates away from a page before the data arrives. It also handles the conversion of responses into JSON by default, which saves a lot of boilerplate code.
Since we are talking about the HTTP layer, I want to ask about interceptors. Specifically, can you explain the relationship between an HTTP client interceptor and your API calls?
I view an HTTP client interceptor as a middleman. When you make an API call using the HTTP client service, the request does not go straight to the server. Instead, it passes through a chain of interceptors. These interceptors can see the request, modify it, or even block it entirely before it ever leaves the browser. The same happens with the response. The interceptor catches the server's response first, allowing you to handle global errors or transform the data before the component that requested it ever sees it. This is where I handle cross-cutting concerns. For example, instead of adding an authentication token to every single API call in every service, I do it once in an interceptor.
You mentioned modifying the request in that interceptor. Since request objects are immutable, how do you actually change a header or a query parameter?
That is a key detail. Because the request objects are immutable, you cannot simply change a property on the object. Instead, you have to use the clone method. Inside the intercept method, I take the request object and call clone, passing in the modifications I want to make, like a new set of headers. Then I pass that cloned request to the next handler in the chain. This ensures that we are not mutating the original request and that the chain of interceptors remains predictable.
Let's shift gears to performance. In a large-scale app, the default change detection can become a bottleneck. Can you explain the difference between the default strategy and OnPush?
Sure. By default, Angular uses the check-always strategy. This means whenever any event happens in the app, a button click, a timer, or an HTTP response, Angular checks every single component in the entire tree from top to bottom to see if anything needs to be updated. In a small app, that is fine. In a massive app, it is a performance killer. The OnPush strategy optimizes this by telling Angular to skip a component and its entire child subtree unless a specific trigger occurs. Those triggers are usually when an input property reference changes, when an event originates from inside the component, or when the developer manually triggers a check using changeDetectorRef.
Under what specific conditions would you say OnPush is not just a recommendation, but mandatory?
It becomes mandatory in high-performance scenarios where the UI is extremely data-heavy. For example, if I am building a complex dashboard with hundreds of data-bound elements or a real-time data feed that updates every few milliseconds, the default strategy would cause the browser to lag. The CPU would be constantly recalculating the DOM for static components that haven't even changed. In those cases, using OnPush is the only way to ensure the interface remains smooth and responsive.
To make OnPush work effectively, you have to be very careful about how you handle data. This brings up the concept of immutability. Why is immutability so important when you are using OnPush or managing state?
Immutability means that once an object or array is created, you don't change it. If you need to update a value, you create a brand new copy of that object with the updated data. In Angular, this is crucial because of how change detection works. If I mutate an object by changing a property inside it, the reference to that object stays the same. If a component is using OnPush, it only looks at the reference of the input. If the reference hasn't changed, Angular assumes the data hasn't changed and won't update the screen, which leads to bugs where the UI is out of sync with the state. By using immutable patterns, we change the reference entirely, which signals to Angular immediately that it needs to refresh the view.
That's a great explanation. Now, imagine you are designing the API interaction layer for a new enterprise project. How would you structure it to ensure it is both reusable and testable?
I would start by completely decoupling the API logic from the components using a dedicated service layer. I would never call HTTP client directly inside a component. Instead, I would create specific services for each domain, like a product service or order service. These services would handle the HTTP requests and map the raw JSON responses into strongly typed models or interfaces. To take it a step further, I would implement a base API service that handles the common logic, things like timeout management, global error handling, and the standard request structure. This makes the architecture very clean. For testability, this structure allows me to easily swap the real API services with mock services during unit tests. I can test the business logic of my components without ever needing a live backend server.
Let's talk about state management. In these enterprise apps, prop drilling becomes a huge issue. How would you structure global state? Perhaps using something like NGRX or NGXS to avoid that.
To avoid prop drilling, I would implement a centralized store based on the single source of truth pattern. Instead of passing data down through 5 layers of components via inputs, the data lives in a global state object. Components then use selectors to pull only the specific slices of data they need directly from the store. When a component wants to change the data, it doesn't modify the state directly, it dispatches an action. That action is handled by a reducer, which creates a new state based on the action. This decouples the components entirely. They only care about the data they display and the actions they trigger, regardless of where they are located in the component tree.
What if you are in a situation where you can't use a full-blown library like NGRX? If you have multiple services modifying the same piece of data, how do you ensure all components react to those changes reliably?
In that case, I would implement a lightweight state management pattern using a behavior subject inside a single dedicated data service. I would make the data source private so that no other service or component can modify it directly. Then I would expose that data as a read-only observable. Any service that needs to update the data must call a specific method in this central service that calls next on the behavior subject. Because a behavior subject always holds the current value and emits it to all active subscribers, every component listening to that stream will automatically receive the latest update, no matter which service triggered the change.
I like that approach. Let's move to forms. Angular gives us 2 main paths, template-driven and reactive. Can you explain the conceptual difference and why you would choose one over the other?
The main difference is where the logic lives. Template-driven forms are more like the old AngularJS style. Most of the logic is in the HTML template using directives like ngModel. They are great for very simple forms, but they are harder to test because the logic is tied to the DOM. Reactive forms, on the other hand, move the logic into the TypeScript class. You explicitly create form controls and form groups. This gives you much more control, especially for complex validation or dynamic fields. It also makes unit testing much easier because you can test the form logic without even rendering the HTML.
You mentioned that reactive forms are better for complex logic. In what way exactly do they improve upon template-driven forms in a professional environment?
The biggest improvement is the level of precision and scalability. Since reactive forms are based on observable streams, I can react to every single keystroke in real time using RxJS operators like debounce_time or distinct_until_changed. This is almost impossible to do cleanly with template-driven forms. Additionally, the model-driven approach means the state of the form is explicitly defined in the code, which makes it much easier to implement conditional validation, like making a field required only if another field has a certain value.
Let's talk about some more advanced integration. Suppose you are integrating Angular with a web component library, like Litelement. What advanced techniques do you need to ensure proper two-way binding and lifecycle synchronization?
That is a challenging scenario because you have to bridge the gap between Angular's zone-based change detection and the browser's native DOM events. For data flowing from Angular to the web component, standard property binding works fine. But for data flowing back, we have to listen for custom events emitted by the web component. To get true two-way binding, I would implement a wrapper component or a directive that listens for those events and then updates the local Angular state. For lifecycle synchronization, I rely on ng after view init to interact with the component, because the element might not be fully upgraded until it is attached to the DOM. Also, if the web component has its own internal state, I would use a shared service to keep the two in sync and avoid infinite update loops.
That sounds like a solid plan. Now, regarding the UI, if you are dealing with massive lists of data, say thousands of rows, how would you handle that without killing the browser's performance?
I would use virtual scrolling. The problem with massive lists is that adding thousands of elements to the DOM slows down the browser and consumes a huge amount of memory. Virtual scrolling solves this by rendering only the small subset of items that are actually visible in the user's viewport. As the user scrolls, the system dynamically swaps the content of those few elements or shifts their positions to mimic a long list. This keeps the DOM tree lightweight and significantly reduces the number of change detection cycles and style recalculations the browser has to perform.
Last few technical questions. If you need to initiate a navigation change between routes programmatically, what method do you use?
I use the router service, specifically the navigate method. It takes an array of commands as the first argument and an optional object for navigation extras as the second. While navigate by URL is available for absolute paths, I generally prefer the navigate method because it is more flexible for passing parameters and navigating relative to the current route.
And just to wrap up the technical side, can you tell me about ng modules? In the newer versions of Angular, we see more standalone components, but the concept of the module is still around in many projects. What is its primary purpose?
An ng module is essentially a way to organize the application into conceptual blocks. It is a container that tells Angular which components, directives, and pipes belong together. It also manages dependencies by specifying which other modules are needed and which components should be exported to be visible to other parts of the app. Every app has a root module, usually the app module, which serves as the entry point. While standalone components are reducing the need for ng modules in new projects, the concept of grouping related functionality remains a core part of how Angular organizes the dependency graph.
Thank you. Those were very thorough answers. To wrap things up, you mentioned earlier that you enjoy mentoring juniors. If you saw a junior developer consistently using the default change detection in a very heavy component and mutating objects directly, how would you approach that conversation?
I would use it as a teaching moment rather than just correcting the code. I would probably start by showing them the performance impact using the browser's profiling tools so they can see the excessive change detection cycles for themselves. Then I would explain the concept of immutability and how OnPush can stop those unnecessary checks. I would guide them through refactoring one small part of the component to use a spread operator for updates and switching to OnPush, then showing them the difference in the profiler. The goal is to help them understand the why, not just the how, so they can apply it to future tasks.
I appreciate that approach. It sounds like you have a very strong grasp of both the technical implementation and the architectural side of Angular. We have everything we need for now. Do you have any questions for us?
I do. I am curious about the current state of your codebase. Are you moving towards a fully standalone component architecture, or are you still heavily utilizing ng modules? And also, how does the team handle the balance between delivering new features and managing technical debt?
Those are great questions. We are actually in the middle of a transition to standalone components. So that would be a project you could help lead. As for tech debt, we dedicate one sprint every quarter specifically to architectural cleanup and performance optimization, which sounds like it would align well with your interests.
That sounds like a great fit. I really enjoy the process of optimizing systems and cleaning up architecture.
Excellent. Well, thank you for your time today. We will be in touch very soon regarding the next steps.
Thank you. I look forward to hearing from you. Have a great day.